Honestly, ma'am, we can begin, ma'am.
Om Shahana Bhavatu Shahano Bhunaktu Shaho Birjam Karvavahai Tejashina Vaditamastu Ma Vidvishavahai Om Shanti Shanti Shanti. Yes, Anindita, now you can start the lecture. So who will start? Anusri? Hello?
Yes,
Am I
sir.
audible?
Yes, sir. Yes, sir.
So Anusri will start, right? So Anusri, you can share.
Okay. Is it visible? Hello, is it visible?
Yeah, it's now visible.
Yes, yes, visible.
Okay. Before starting the practical portion, I would like to know from the participants, what do you mean by the differential validity? Anyone, please? Anyone?
It is the difference between the validity of it is the difference between the subgroups in the validity coefficient.
It's the difference between the correlation coefficient or the validity coefficient between the two variables across different subgroups of the population.
Yes, yes.
Okay. So suppose you are you were checking the relationship between the intelligence test and the academic achievement and on a whole population, and you find out that on this particular intelligence test that taste is the correlation coefficient is higher in case of the people, in case of the students who lives in the urban area, and the correlation coefficient is lower in case of the people of the rural area. So is the taste is good? Is it good? Is it fair to the whole population? No, because the taste is biased towards the urban students. But the taste should be fair to the whole population. For that particular reason, we are checking the differential validity of a test so that we can detect, is there any biasness of this particular test? If there is bias, we have to reduce the bias by redesigning the test. Okay. Is this clear?
Yes, yes.
Okay. So I'm going to start this practical portion. Here you can see the data, that is the data of a population of a sample. And those are the two variables. One is academic achievement, another is the verbal reasoning test. We will check the correlation coefficient between the academic achievement and the verbal reasoning. That means is there any relation between the academic achievement and verbal reasoning? If there is any relation, is it same for the whole population or is it biased to any subgroups? And the subgroups here are divided into several caste categories. Okay, so I have written here the caste. 4 is indicated, here you can see 4, 2, 1, 3. So 1, 2, 3, 4 is there. 1 is indicated as the ST category. I'm writing here. Caste 1, ST. Caste 2 is C. Caste 3, OBC. Caste 4, unreserved category, so UR. Okay, so 4 is indicated as unreserved category, 3 is indicated as OBC, 2 is indicated as scheduled caste or SC, and 1 is indicated as scheduled tribe or ST. Okay, so we will check whether there is a correlation between the academic achievement and the verbal reasoning. It differs between the subcategories of the castes, or is it same for the total population? So first we will check the correlation coefficient for the whole population. Before that, I will arrange the order from this caste categories from shortest to the largest. So I will select it out. Short and filter. Short smallest to largest. Short. So I got it. That is from 1 to 3, 4. So from 1 it started. Now I will check the correlation between the academic achievement and verbal reasoning for the whole population. So equal to correlation. So correlation. Then I will select 2084. So,
Ma'am, you can press Control Shift down so that you can select all at once.
yes. It will be B2 to B2084, comma, C2, B2084. The data is very much large data. So I got the correlation coefficient for the whole population, that is 0.52092. Now I have to check the correlation across the sub-caste categories. First one. Now I have to select all the 1. Okay. Because I am trying to find out the correlation coefficient for the caste 1, that is ST. So I will select only the 1. Two. This is B2 to B174, that is academic achievement, and then C2 to C174, that is verbal reasoning. Bracket close. So we got it for the caste 1, that is 0.51 or 0.52. Now for caste 2 is C. So I will select from the 2.
Already sorted. Why don't you filter it on column D? So you'll just choose that.
Yes.
No, since it's already sorted on the column D, just put a filter on column D and select only 2. So you'll just go to the cell the items of it. So it's easy for you, right?
Once she removes the filter for the next number, then the formula will get affected.
No, but I can see. Okay.
So I got the first 2, the correlation coefficient is 0.53. Caste 3, that is OBC. I have to select from the 3. So it's 91.
There is missing B there.
Yes. So it is 0.75 for caste 3. Two. So all the correlation coefficient across the subcategories are on the basis of the castes. So we can see here the highest correlation coefficient is there for the caste tree. That means the taste is not at all bias free, isn't it? Hello?
Yes, ma'am.
It's kind of biased.
The taste in case of this, all of this castes, the caste 1 that is 0.51, caste 2 that is 0.53, for the caste 3 that is the huge difference there, that is 0.75, and in case of the caste 4, the correlation coefficient is very low. That means the taste is biased towards the caste 3 category for the OBC. That means we have to redesign the taste again to make it bias free. So our purpose of this, making this differential validity, is to check whether there is any biasness or not. Is it clear up to that?
Yes.
Okay. Now we can do another thing, that is making the scatter plots. Making the scatter plots for the caste 1, caste 2, caste 3, and caste 4. So I'll select. I'm going to select the caste 1. So I took all the 1, then insert, scatter. Now I will select one plot, right click at trend line, linear. Okay, this is the scatter plot for the first one. I can find in chart title area. So first one. Now I will do for the 2, first 2. So I've taken all the two. Again, insert, scatter. French line, linear. Okay. Then for 3. First 4.
Ma'am, please press Control, Shift, and down together so that it gets selected fully.
Yes, yeah, I already shifted it. Press the shift. So those are the scatter plots. You can see here four scatter plots are different from each other. Do you know what is scatter plot? In which purpose we use it? See, this is the scatter plot for the cast 1. And this is the based fit line. Okay. Anyone know what is a scatter plot? Can anyone say?
It's more about deploying your numbers to say that whether where exactly that all the calculation or derivations is positioned. It's near to that line or like more of like outliers are lying. Primarily starts from the linear regression kind of concept. What happens here?
Yes, linear regression. Yes.
So that
this,
It is like
go
a
ahead, go ahead.
distribution, right?
These plots are the points, data points. That is the x-axis versus y-axis, the individual's data points on the verbal reasoning test versus the academic achievement test. Okay. And the based fit line that indicates that the line that best expresses the relationship between those points. Okay. So the points that will fall on the line, the better the correlation, the tighter the points will hug the line. Okay. So you can see in case of the cast tree, the plots are very much concentrated on the best fit line rather than the cast 1, cast 2, and cast 4. Because the correlation coefficient is very, very high in case of the cast tree, and so that the plots are very much converged on the best fit line. This is for cast 2, that is not very much converged. See here, cast 3. You can see the total difference from the cast 1, cast 2. The cast 3, the scores are, the plots are very much converged, very much concentrated on the best fit line. So that indicates the better the relationship between these two variables, the plots will be so much converged, so much concentrated on this best fit line. Okay. Is it clear?
Yes.
Yes, ma'am. Yes, ma'am.
Here, the scatter plot of the cast 4, and you can see here the score, the plots are very much scattered from the best fit line. They're not at all concentrated, not at all nearly scattered. It is almost away from the best fit line, isn't it? Because the correlation coefficient for this cast 4 is very much low. So the scores are very much scattered from the best fit line. Okay. Clear? Hello?
Yes.
Okay, so this is the procedure of the calculating the differential validity of a test. Through differential validity, we can check, we can detect whether there is any bias in a test. If there is any bias, then we can redesign the test to make it fair to the whole population. That is our purpose to do this differential validity. Okay.
So that here it's a cast like this. It can be anything, right? So demographic or
Yes, it can be anything. It can be the gender. It can be different ethnic groups. It can be the demographic details, whatever.
so if the questions are aligning to the particular segment of that, so is there any specific reason? Or is it because of the purpose of this entire test is cover all the segments of that particular demographic or something, or like, because what I'm trying to understand here is if it's aligning to the particular segment of the people or group of the people, wouldn't it be more efficient to just apply the test to only that segment so that you get more processed information on that particular segment?
Can you repeat? I can't follow you. Sorry.
No issues. So what I was saying here is, if this correlation coefficient is proving that it only works with only particular segment of the samples or the population, whatever you are talking about. So rather than working on completely changing for making sure that all other things also aligning to the what was that, the best fit curve or something like that, would it be wiser to go just make sure that fine tune further for the particular segment of the sample which is already working fine? because here that variation is too huge, right? So one is having a 7.7, other one is having 0.4,
Yes.
wherein other two is having 0.5, 0.5 is having, and overall correlation also is a 0.59 is coming up. So considering this, what I'm trying to understand here is it worth to for such a huge sample to redo that entire process of revisiting the samples and questions and everything and do the testing again? Or that's how it should be done?
Yes. Actually, this is the problem solving approach. Okay. This validity is at the psychometrics purpose. We are using the validity techniques for the psychometrics purpose, but this differential validity is very much about the applied psychometrics, because this is based on the problem solving approach. Actually, whenever we are trying to find out this validity coefficients, the correlation coefficient between the predictor and the criterion variable, we assume that the correlation coefficient should be same for the whole population. So whenever we are doing any making any new test, any new psychological test, we are assuming that the test should be the correlation between the two variables, or between the predictor and the criterion variable, that should be same for the whole population. But sometimes we can find it out that whenever we are trying to do this in the practical field, we can find it out that the correlation coefficient differs across the subgroups. That is not expected at all. Okay, so actually we are doing this in case of the pilot study. Before administering the test on a whole basis, on a final basis, we are doing it before that, for in case of the pilot study, so that we can understand whether there is any biasness. If we try to detect this biasness before administering it finally, that will be helpful for us to do it. Okay.
Okay.
And another thing I like to clarify, I have watched your previous class video, that I think you have asked about that the statistical techniques are used for the validity, and that is not very much appropriate or very much needed for reliability, but that is not at all true. Whatever the reliability, validity, whatever it is, the norm establishment, whatever it is, you have to do the statistical analysis. That is mandatory. Okay, because without the statistical analysis, you can't prove anything. Suppose you are checking the retest reliability of a particular test. Okay, so first you administered the test once on a sample, and after 2 weeks of the first administration, you have you administered the test again on the same sample. So you have recorded 2 sets of responses on the first administration and for the second administration. Now, how can you say on the basis of your observation that the test is reliable or the test is not reliable? How can you say? You can't say it, no? You can't say it. For that purpose, you have to do the correlation coefficient between the first responses and the second responses. The responses from the first administration and the responses from the second administration. If the correlation coefficient is positive and very high, then you can say this is the reliable test. So whatever it is, reliability, validity, you have to do the statistical analysis, and that is mandatory. Okay. On the basis of the eye observation, you can't say anything. Is it clear?
Yes, ma'am. I have one question. So here we saw that for cast 3, the correlation was high and above what was the overall, and in case of cast 4, it was lesser than the overall. And it also deviated. So here, do we address both the address the question? I mean, change the questions so that we get you so that we have to modify the questions for both the cast 3 and cast 4, is it? Or
yes. You have to modify the questions on the basis of that, so that the correlation coefficient will be same for all the cast categories. It shouldn't be differ. In that case, we can see that the test is more biased towards the OBC category, and that is more biasful towards the, I think, unreserved category.
Yes.
That means the unreserved category are victimized here, isn't it? unreserved category are victimized here. So that shouldn't be. That shouldn't be. For that particular purpose, we will redesign the test so that, and again we have to check the correlation coefficient, and that should be same for the, that should be similar to the overall population.
Sure. So, what is the admissible range around which we can have these correlations? It cannot be exactly the same, but what would be the admissible range with regard to the overall correlation that we obtain?
No range is there like that it should be, it shouldn't be, nothing like that. But whatever it is, it should be, it is like, first you have to check the overall population so that you can understand this is the range, okay? In
So,
case of
for
this,
instance, over here we saw it was around 0.52. For caste 1 and 2, it was between 0.52 and 5.3.
yes.
So, is that all right? So, can it be between 0.51 and 5.3? Where, but the overall correlation that we found was 0.52. I'm asking like that. Would that be all right?
In case of the caste 1 and the caste 2, that is all right, no? That is very much nearer to the overall population correlation coefficient. So
Sure.
this is okay for this particular purpose. But in case of the OBC category and the unreserved category, those are very much far away from the overall population. So we have to do it. We have to redesign it for the OBC and the unreserved.
Sure. Thank you.
Okay. So I'm stop sharing. Is there any question, or Anamita, you can proceed.
Are we going to have any additional session now, or like, are we done?
No, I have done.
Oh, okay. Mr. Roy, Ishani, Anindita, do we have any further discussion now, or like, are we done with session?
I think we are done.
Done for today. Okay. Okay, then thanks a lot, everyone. Cheers.
Thank you.
Are we going to have any further discussion now?
I don't have any. I have completed, but I don't know whether Sai or Anindita has anything to do. Ask her or ask Sai.
Hello, is it clear to all of you? Hello.
Yes,
Yes,
sir.
sir.
Yes, sir.
So what is the difference between validity in the psychometric approach and the differential validity, that is applied psychometric approach? Can anybody tell? Why this differential validity is in applied psychometrics? Srishti?
As part of theory, basic theory, we understand the correlation, the validity of a tool. Whereas in applied psychometrics, you're trying to apply to different subsection of a particular population across a in a particular dimension. So it's under the applied psychometrics.
Something more, think about it. Dharani Dharan, can you tell me?
When we use the differential validity in a practical setup, it would be more helpful to bring about the clarity across clarity in results across the two subgroups that we intend to measure.
So generally in the book of psychometrics, you will not find the differential validity. Okay. Because the psychometrics, they are mainly dealing with the item characteristics, item properties, taste properties, etc. But when we are applying the psychological test for problem solving, okay, there you can find the applied psychometrics. So when you will confronted with the problems and you want to find out some solution, then you can think about the applied psychometrics. Okay.
Yes, sir.
And specifically in case of the differential validity, we find that is a subgroup of population, the correlation structure varies, right?
Yes, sir.
So the subgroup of population, correlation structure varies. And based upon that, we can develop our model.
Sure, sir. I understand.
Yes,
Okay.
sir.
Okay, thank you.
Thank you, sir.
So you find that is this particular
Thank you, sir.
class is useful for you, right? Dharan Srishti?
Yes, sir.
Yes, sir.
Okay. So Anindita, do you like to add something? Hello, Anindita, are you here? Okay, maybe some net problem. So I'm requesting all of you, please close your hands. Oh, Purnamada, Purnamidam, Purnamudachyate, Purnasya, Purnamadaya, Purnameva Vashishyate. Om Shanti, Shanti, Shanti. Okay, good night.